March 1944. Rechlin, Germany. The B-24 Liberator sat on the tarmac like a captured giant, engines silent, olive-drab paint scarred by flak. Wehrmacht engineers circled the bomber with notebooks and calipers, measuring every rivet, cataloging every system, searching for secrets they already knew they wouldn't find. They found something worse than secrets. They found scale. The bomber had come down over occupied France 3 weeks earlier. Crew bailed out. The aircraft landed wheels up in a muddy field near Amiens, relatively intact. Luftwaffe recovery teams hauled it to Rechlin, the Reich's primary flight test center, where Germany's best aeronautical minds waited to dissect Allied technology. They'd done this before. Captured Spitfires, downed fortresses, Russian Yaks. Every enemy aircraft became a classroom. But the Liberator taught a different lesson. The engineers started with the obvious: dimensions, weight, armament. They measured the wingspan, 110 feet. They counted the gun positions, 10 Browning .50 calibers. They inspected the bomb bay, 8,000 pounds of ordnance capacity. They ran their hands along the fuselage, feeling the quality of aluminum skin, checking thickness, noting construction methods. Standard intelligence work. Then they opened the engine cowlings. 4 Pratt & Whitney R-1830 twin Wasp radials stared back at them. Each engine displaced 1,830 cubic inches. Each produced 1,200 horsepower at takeoff. The engineers photographed every angle, sketched every component, removed panels to expose the accessory sections. They found superchargers built to exacting tolerances. They found ignition systems using materials they recognized but couldn't readily source. They found fuel injection assemblies manufactured to specifications that required machinery Germany was rapidly losing. One engineer, a former BMW works manager named Klaus Hermann, spent 2 hours examining a single carburetor. He wrote in his report that the precision of American mass production exceeded what his Munich factory achieved with hand-fitted prototypes. The carburetor bore no individual craftsman's marks, no hand-filing marks, no adjustment scratches. It emerged from American production lines identical to thousands of others, machined to tolerances that required no finishing work. That was day 1. Day 2 brought systematic disassembly. The team separated hydraulic systems from electrical systems. They traced control cables. They mapped fuel lines. They documented the bomber's Sperry autopilot, a device that allowed crews to fly hands-off for hours during long missions over the Reich. German bombers had nothing comparable. The Luftwaffe relied on pilot skill and endurance. The Americans built machines that reduced human fatigue to a tactical footnote. The engineers found electric actuators where German designs used manual controls. They found redundant systems where German aircraft had single points of failure. They found a nose-wheel assembly that weighed less than comparable German designs while supporting heavier loads. The tricycle landing gear configuration itself represented a philosophical difference. American engineers prioritized ease of ground handling over structural simplicity. Every discovery added weight to an unspoken conclusion. The B-24 wasn't elegant. It wasn't beautiful. The fuselage had a slab-sided appearance that German designers would have rejected as aesthetically unacceptable. The Davis wing, while efficient, looked ungainly compared to graceful Luftwaffe curves. It didn't showcase revolutionary aerodynamics or radical engine concepts. It showed something more devastating: industrial efficiency at a scale Germany couldn't approach. American factories were building these bombers at a rate that defied German comprehension. Ford's Willow Run plant in Michigan assembled one complete B-24 every 63 minutes at peak production. 63 minutes. The facility employed 42,000 workers operating 3 shifts. The assembly line stretched over a mile inside a single building covering 67 acres under roof. German intelligence knew these numbers. The engineers at Rechlin knew these numbers. Knowing didn't make them less impossible. Germany's entire bomber production for 1944 would total roughly 2,200 aircraft across all types. Willow Run alone delivered 6,791 B-24s that year. One American factory outpaced the entire German aviation industry, and Willow Run was just one plant. Consolidated built Liberators in Fort Worth and San Diego. Douglas built them in Tulsa. North American contributed components in Dallas. The geographic distribution itself revealed strategic depth Germany couldn't match. American aircraft production spread across a continent protected by two oceans. German factories clustered in the Ruhr, Bavaria, and Saxony, all within range of Allied bombers. By March 1944, 8th Air Force raids targeted aircraft plants weekly. Factories moved underground. Production scattered into forests. Efficiency collapsed. The engineers wrote their reports. The reports went to Berlin. Berlin already knew. But the story of the stripped B-24 isn't really about a single bomber. It's about the moment German technical excellence confronted American industrial capacity and lost. Consider the numbers from different angles. The United States manufactured 18,482 B-24 Liberators during the war. Total production. Germany built approximately 1,400 Me-262 jet fighters, the most advanced aircraft of the conflict. The Me-262 could outfly anything in the Allied arsenal. It arrived too late, in too few numbers, hampered by strategic decisions that guaranteed irrelevance. The jet fighter program began in 1938. Engineers at Messerschmitt conceived an aircraft powered by turbine engines rather than pistons. The concept was sound. Willy Messerschmitt himself championed the design, despite skepticism from Luftwaffe traditionalists who viewed jet propulsion as experimental fantasy. The execution was brilliant. The first test flight occurred in July 1942 using Jumo 004 turbojets. The aircraft reached 520 miles per hour in level flight. No Allied fighter could match that speed, but speed alone doesn't win wars. Production does, logistics does, fuel does, pilot training does, strategic clarity does. Germany had none of these advantages by 1944. The Me-262 required roughly 1,500 man-hours to build under optimal conditions. Reality was never optimal. Dispersed production added transportation delays. Shortage of specialized tools slowed assembly. Allied bombing disrupted component deliveries. The actual time from parts to completed aircraft stretched to months. A B-24 required approximately 2,500 man-hours, despite being larger and more complex. American factories achieved efficiency through standardization, specialized tooling, and assembly line methodology borrowed from automotive manufacturing. Henry Ford applied the same principles to bombers that revolutionized automobile production. Workers installed specific components at fixed stations. Aircraft moved past them on carefully timed schedules. The system demanded precision planning, but minimal individual skill. German aircraft production relied on skilled craftsmen working in dispersed facilities, often underground, constantly disrupted by Allied bombing, perpetually short of raw materials. A Messerschmitt plant near Regensburg employed master mechanics who understood entire airframes. They could diagnose problems, improvise solutions, substitute materials. They were artisans building weapons. Americans were factory workers assembling modules. Both approaches produced aircraft. One scaled indefinitely. The other hit capacity limits determined by available skilled labor. The jet engines themselves presented challenges that German industry couldn't overcome. Each Jumo 004 turbojet used special alloys to withstand extreme temperatures, exceeding 1,500 degrees Fahrenheit. Turbine blades required heat-resistant steel containing chromium and nickel. Germany lacked sufficient chromium and nickel. Engineers substituted inferior materials. Engine lifespan dropped to 25 hours between overhauls. Some engines failed after 10 hours. 25 hours meant a jet fighter might complete 15 combat sorties before requiring complete engine replacement. Compare that to American piston engines running hundreds of hours between maintenance. The R-1830S and the Rechlin Liberator had logged over 300 hours each before the aircraft went down. Maintenance crews expected 500-hour intervals between major overhauls. American engines used superior metallurgy, benefited from better quality control, and operated within design parameters that prioritized reliability over maximum performance. German jet engines pushed boundaries because they had to. American piston engines met requirements because requirements were realistic. Fuel added another layer of impossibility. The Me-262 consumed J-2 jet fuel, essentially kerosene, at a rate that strained Germany's collapsing petroleum infrastructure. A single jet consumed approximately 330 gallons per hour at combat power. Fuel capacity of 2,205 liters meant endurance under an hour at full throttle. Allied bombing of synthetic fuel plants throughout 1944 reduced aviation fuel availability to critical levels. The Luftwaffe grounded entire fighter wings for lack of fuel, while Me-262s sat idle on dispersal fields, beautiful and useless. Romanian oil fields, Germany's primary natural petroleum source, fell to Soviet forces in August 1944. Synthetic production from coal liquefaction plants became crucial. Those plants became priority targets. By December 1944, aviation fuel production dropped to 26,000 tons monthly, down from 175,000 tons in April. The gap couldn't be bridged. Pilots sat in ready rooms while jets sat unfueled 50 meters away. Pilot training suffered similar attrition. Creating a jet fighter pilot required months of specialized instruction. Students needed experience in conventional aircraft first, typically 150 hours minimum. Then, transition training in the jets. But by 1944, the Luftwaffe couldn't spare experienced pilots for training duty. Combat losses exceeded replacement rates, fuel shortages curtailed flight hours, training schools reduced curriculum. New pilots arrived at operational squadrons with minimal preparation, expected to master revolutionary aircraft while flying against battle-hardened Allied crews. Experienced pilots adapted to jet performance relatively quickly. The speed advantage compensated for learning curve challenges. But replacing losses proved impossible. Each veteran shot down represented not just one dead pilot, but hundreds of hours of irreplaceable experience. Training replacements required fuel Germany didn't have, instructors committed to combat, and time the Reich no longer possessed. The engineers at Rechlin understood these constraints intellectually. The stripped B-24 made them visceral. They could see American industrial philosophy embodied in aluminum and steel. Every component reflected a manufacturing system optimized for mass production. Standardized fasteners used A.N. Army-Navy specifications. Interchangeable parts meant any component fit any aircraft. Modular assemblies allowed subcontractors to build sections independently, then ship them for final assembly. The bomber was designed to be built quickly by semi-skilled workers using specialized jigs and fixtures. Quality control relied on process rather than craftsmanship. One engineer noted that the B-24's electrical system used color-coded wiring throughout, red for positive, black for negative, specific colors for specific circuits. A mechanic needed minimal training to trace problems or replace components. German aircraft used whatever wire was available. Mechanics learned through experience and referred to detailed schematics. German aircraft production prioritized performance over producibility. Engineers designed aircraft to maximize capability, then figured out how to build them. Americans designed aircraft to be built, then maximized capability within manufacturing constraints. The philosophical difference created tangible results. Germany produced superior individual aircraft. America produced superior numbers. The Rechlin team found evidence of this everywhere. Electrical wiring harnesses used color-coded insulation for easy identification during assembly and maintenance. Hydraulic fittings followed standardized thread specifications. Access panels opened with common tools. The Americans built the bomber assuming that mechanics in the field would need to replace components quickly, often in darkness, possibly under enemy fire. German aircraft mechanics were skilled technicians who understood complex systems. They could rebuild carburetors, rewire ignition systems, fabricate replacement parts from raw stock. American aircraft mechanics were trained to replace modules and check function. One system required expertise, the other required process. Both worked, one scaled. Look at sortie rates. The 8th Air Force, operating from England, launched over 330,000 bomber sorties during the war. The 15th Air Force, flying from Italy, added another 148,000. These bombers struck targets across the Reich daily, often in formations exceeding 1,000 aircraft. They dropped 2.7 million tons of bombs on occupied Europe and Germany. Individual missions tell the story more clearly than aggregate statistics. On March 6, 1944, the same month engineers examined the captured Liberator, the 8th Air Force launched 730 bombers against Berlin. 672 reached the target. They dropped 1,626 tons of bombs. 69 bombers were lost. The 8th Air Force replaced those losses within a week. The Luftwaffe couldn't counter this volume. Germany's fighter force shot down thousands of Allied bombers, inflicted horrific casualties on bomber crews, forced tactical adjustments that changed how Americans prosecuted the air war. But the math was inexorable. Allied factories built replacements faster than German guns could destroy them. By March 1944, when the engineers examined the captured Liberator, the air war was already decided. Germany just hadn't accepted defeat. The Me-262 represented a last technological hope. If jet fighters could be produced in sufficient numbers, if pilots could be trained to exploit the aircraft's speed advantage, if fuel could be found, if spare parts could be manufactured, if Allied bomber formations could be disrupted effectively, then maybe the strategic balance might shift. Every assumption was wrong. Hitler complicated matters by demanding the Me-262 serve as a bomber rather than pure fighter. The Führer fixated on retaliation for Allied bombing raids. He wanted aircraft that could strike back, carry bombs deep into enemy territory, punish British and American cities. Converting the Me-262 to a fighter bomber role required modifications that delayed production, compromised performance, and diverted resources from more critical needs. The directive came in November 1943. Engineers protested that the aircraft was designed as an interceptor. The airframe could carry bombs, but doing so negated the speed advantage. Fighter-bomber missions required different tactics, different training, different operational concepts. Test pilots demonstrated the aircraft's fighter capabilities. Luftwaffe commanders argued for deploying jets as bomber-destroyers. Hitler insisted. Months passed. The war moved forward. Göring, head of the Luftwaffe, lacked the political capital to override Hitler. He'd promised in 1940 that no enemy bomber would reach Berlin. Allied raids made that promise a bitter joke. His influence waned. His advocacy for the Me-262 as a fighter carried no weight. The jet program stalled in bureaucratic conflicts while Allied bombers struck German cities with increasing impunity. By the time the first operational Me-262 fighter units began combat operations in September 1944, the Reich was contracting on all fronts. The Normandy invasion succeeded. Paris fell. The Red Army advanced through Poland, Romania, and the Balkans. Allied bombers struck German cities with impunity. Fuel stocks dwindled. Experienced pilots died. Factory output faltered. The jet fighters scored kills. They demonstrated technological superiority in individual engagements. Pilots developed tactics exploiting the Me-262's speed. They approached bomber formations from ahead, dove through at high speed, fired brief bursts with 30mm cannons, then escaped before escort fighters could respond. Allied crews called them blowjobs, fast attacks that appeared from nowhere and vanished before defensive fire could track them. Major Walter Nowotny, a Luftwaffe ace with 258 confirmed kills, commanded the first operational jet unit. He shot down 3 B-24s in his first jet combat mission. He died 3 weeks later when his aircraft suffered engine failure during takeoff and crashed. His death illustrated the program's fundamental problem. Brilliance couldn't overcome systemic failure. Production numbers tell the story more clearly than combat reports. Germany manufactured roughly 1,400 Me-262s before the war ended. About 800 reached operational squadrons. Far fewer flew combat missions simultaneously. Allied intelligence estimated no more than 200 jets were ever operational at one time. Most sat grounded for lack of fuel, spare parts, or trained pilots. Compare that to Allied fighter production. The United States built over 15,000 P-51 Mustangs, over 20,000 P-47 Thunderbolts, over 10,000 P-38 Lightnings. Britain produced thousands of Spitfires and Tempests. The Soviets fielded tens of thousands of Yaks and Lavochkins. The Me-262 was objectively superior to any of these aircraft in performance. It couldn't be everywhere. It couldn't patrol constantly. It couldn't replace losses. It couldn't overcome mathematics. The engineers at Rechlin knew this. Their report stated it explicitly. One analysis, filed in April 1944, concluded that Germany lacked the industrial capacity to produce advanced aircraft in quantities sufficient to alter strategic outcomes. The author, an aeronautical engineer named Dr. Friedrich Seewald, recommended focusing resources on ground-based defenses and conserving experienced personnel for post-war reconstruction. The report was filed and ignored. Germany continued building jets. Factories dispersed into forests and tunnels, trying to escape Allied bombing. Workers assembled aircraft in caves using hand tools. Production rates dropped. Quality suffered. Engines failed during test flights. Completed aircraft sat unfueled. The Oberammergau facility in Bavaria moved into abandoned mine shafts. Workers descended underground each morning to assemble jet components in caverns lit by electric lamps. Ventilation was inadequate. Safety was minimal. Production was sporadic. The facility delivered 47 completed Me-262s before American forces captured the site in April 1945. Similar stories repeated across Germany. The underground factory at Kalle in Thuringia employed concentration camp labor to excavate limestone caves for jet production. Thousands died creating space for aircraft that would never fly. The facility completed 12 jets. The final Me-262 units fought with desperate effectiveness through early 1945. Pilots achieved remarkable kill ratios against Allied bombers. They developed tactics exploiting the jet's speed to slash through escort formations, fire, and escape before enemy fighters could respond. Adolf Galland, one of Germany's most respected fighter commanders, led JV-44, an elite unit flying Me-262s during the war's final months. His pilots were veteran aces flying the world's best fighter. They shot down dozens of Allied aircraft. They changed nothing. They couldn't stop the inevitable. By April 1945, fuel shortages grounded most remaining jets. Allied armies overran airfields. The Luftwaffe ceased functioning as a coherent fighting force. The Me-262 program ended with hundreds of incomplete aircraft abandoned in factories, dozens destroyed on the ground to prevent capture, a handful flown to Allied lines by defecting pilots who understood the war was lost. The engineers who examined the B-24 in March 1944 understood this ending before it arrived. They'd measured the evidence, they'd calculated the ratios, they'd compared German capability against American capacity and found the equation unbalanced beyond correction. The stripped bomber on the Rechlin tarmac represented more than a single aircraft. It represented a production system that married engineering efficiency with industrial scale. It represented a strategic approach that valued overwhelming force over individual excellence. It represented a democracy that mobilized its industrial base completely while maintaining distance from combat. Germany couldn't build what America built, not because German engineers lacked skill, not because German workers lacked dedication, because Germany lacked the industrial infrastructure, resource base, and strategic position that made American production possible. The United States possessed vast natural resources within secure borders: iron ore from Minnesota, bauxite from Arkansas, oil from Texas. It maintained manufacturing capacity untouched by enemy bombing. Detroit's automobile factories converted to tank and aircraft production without losing a single facility to air raids. It drew labor from a population of 140 million. It benefited from political stability and economic systems designed for mass production. It entered the war with years to prepare and scale production before committing forces to Europe. Germany fought on 3 fronts simultaneously while Allied bombs destroyed its cities. It scraped for raw materials from occupied territories that resistance movements disrupted constantly. It drafted labor from populations that ranged from unenthusiastic to hostile. It converted peacetime industry to war production while that industry burned under strategic bombing. The Me-262 was magnificent. It proved German technical prowess. It demonstrated innovation under pressure. It arrived as a testament to what German engineers could achieve with inadequate resources and impossible constraints. It arrived too late, in too few numbers to matter. The engineers at Rechlin filed their reports in proper military fashion. They documented every system, every component, every manufacturing detail they could discern from the captured B-24. They compiled data on American production methods, material specifications, and assembly techniques. They noted that many components bore manufacturer stamps from companies they'd never heard of. Subcontractors scattered across American industrial cities, each producing specific parts to exact specifications, all feeding into assembly lines that never stopped. They forwarded their findings to procurement offices, design bureaus, and strategic planning staffs. The reports joined thousands of similar documents describing Allied advantages, cataloging German shortfalls, projecting unsustainable trajectories. Bureaucrats read them, commanders filed them, the war continued. The B-24 sat at Rechlin for several more months. Engineers returned periodically to examine specific systems or test components. Eventually, Allied air raids forced evacuation of valuable equipment. The bomber remained behind, too large to move easily, too damaged to fly. American forces found it in May 1945 during their advance, rusting on the tarmac where German engineers had stripped it bare, searching for advantages they couldn't exploit. The Me-262 lived longer in legacy than in service. Post-war analysis recognized the aircraft as historically significant. Military theorists studied its impact on jet fighter development. The United States and Soviet Union both captured examples and used them to accelerate their own jet programs. Aviation engineers examined its design features, the swept wings, the underslung engine pods, the tricycle landing gear. Historians debated whether earlier deployment might have changed outcomes. The consensus emerged clearly. The Me-262 represented technological achievement, not strategic capability. Individual aircraft performance mattered less than systemic capacity. Tactical superiority couldn't overcome strategic disadvantage. Innovation required infrastructure. Germany's engineers were not inferior. They were overwhelmed. Consider the final numbers. Total German aircraft production from 1939 to 1945, approximately 119,000 aircraft. Total American production for the same period, roughly 300,000 aircraft. Total Soviet production, approximately 158,000 aircraft. Britain added another 131,000. The Axis fought outnumbered 3-1 in the air, and that ratio worsened as the war progressed. The engineers measuring the B-24 in March 1944 confronted this reality through aluminum skin and rivets. They couldn't articulate defeat. Their reports maintained professional detachment, but the conclusion saturated every page. American industry operated at scales Germany couldn't approach with existing methods, available resources, or remaining time. The Me-262 program continued because stopping felt like surrender. Because engineers kept innovating, because pilots kept flying, because admitting impossibility seemed worse than attempting the impossible. The last operational Me-262 sorties flew in early May 1945. Pilots attacked Soviet columns advancing on Berlin. They strafed Allied positions in Bavaria. They defended airspace that no longer existed over a Reich that had ceased to function. They flew because the aircraft existed and fuel could be found, and targets presented themselves. Then they stopped. The jets sat silent on captured airfields. Engineers examined them the way Wehrmacht technicians had examined the B-24. The circle completed. Allied intelligence teams measured, photographed, cataloged. They found brilliant design hampered by material shortages. They found innovative solutions to problems American industry never faced. They found evidence of technical achievement unmatched by strategic impact. The story that began with German engineers stripping a captured bomber ends with Allied engineers studying captured jets. Both sides learned, both sides measured, both sides recognized excellence when they found it. But only one side produced excellence at scale. The Wehrmacht engineers at Rechlin understood this in March 1944. They wrote it in careful language, buried in technical reports, disguised as objective analysis. They documented American manufacturing capability and German limitations. They measured the gap and found it unbridgeable. The B-24 they examined was one bomber among thousands. It represented a system, not an exception. Serial number 42-52534, built at Willow Run in January 1944, delivered to England in February, shot down in March. Ford would build 347 more B-24s that month. Consolidated would add 211. Douglas would contribute 165. The production continued, regardless of individual losses. It proved that winning modern war required more than courage or skill or tactical innovation. It required factories running 3 shifts. It required raw materials flowing uninterrupted. It required training facilities safe from attack. It required fuel in unlimited quantities. It required time to build, test, improve, and deploy. Germany had none of these advantages by 1944. The Me-262 couldn't restore them. No aircraft could. The engineers knew. They wrote their reports. They filed their data. They returned to their work developing weapons for a war already lost, building aircraft that would arrive too late, pursuing excellence in service of inevitable defeat. The stripped B-24 taught them what they already suspected. Sometimes technical superiority isn't enough. Sometimes the better individual solution loses to the adequate mass-produced one. Sometimes seeing the future clearly only sharpens the recognition that the present cannot be changed. The bomber sat on the tarmac at Rechlin, engines silent, secrets revealed, teaching lessons Germany couldn't apply. It remained there until American forces arrived, a monument to industrial capacity and strategic vision, evidence that wars are won not by the best weapons, but by the most weapons, deployed consistently, supplied reliably, crewed adequately, and produced unstoppably. The Me-262 was Germany's answer to that equation. It arrived brilliant and insufficient, a testament to engineering under constraint, a reminder that innovation without infrastructure creates marvels without impact. The engineers who examined the Liberator understood both aircraft told the same story from different angles. One showed what scale achieves, the other showed what scale prevents. Together, they illustrated the central truth of industrial warfare. Capacity determines capability more surely than genius determines design. The war ended. The jets stopped flying. The bombers kept coming until they weren't needed. Production lines at Willow Run continued operating into June 1945, completing aircraft that would never see combat. Workers assembled bombers that went directly to desert storage facilities in Arizona. The production system proved easier to complete than to stop. And in archives across 2 continents, reports documented what engineers learned from a stripped B-24 on a German airfield, lessons about production, scale, and the unbridgeable gap between technical excellence and strategic sufficiency. Lessons written by men who understood the outcome before it arrived, who measured defeat in rivets, and realized that knowing changes nothing when the means to act no longer exist.